it's important that you use the icon. Now, during the class, we'll probably be throwing in some questions. So if some polls will be going around. So please make sure you're participating in every poll that comes up. So this polls will help for us to know that you are understanding what we are teaching. So let's say we have a few sessions that have gone on for like a bit. We'll throw in like a few questions, just simple questions that anybody can answer. So don't worry that it's not an hard question or anything. So just please make sure you're participating in the polls. So another one is that no question is a stupid question. So no matter how lame you feel the question is, no matter how low you feel the question is, anything that you don't understand at all. And by anything, I mean anything at all, no matter how you feel it sounds, ask your questions. Please don't be afraid to ask your questions. Every question is valid and we are here to answer it. All right, so another one is that just like we all know, it's very important and for us to be respectful and professional in the class, just so we can flow better. So if you have your questions, you ask it respectfully. You know, the facilitator is here to answer you. So just make sure you are being respectful and you're professional about the class. Like we all know, data is a very important thing in life. So the last one, I know this might be hard for a lot of people, but it's advised that you keep your cameras on. So just like I'm doing right now, you should also keep your cameras on. What this does is that it helps us in knowing how engaged our students are. So if your cameras are on, it will even help you concentrate better. So please, if you are in a place where you can keep your camera on, your mic can be muted. You should mute your mics, but you can keep your camera on such that you can be engaged. So a quick one, can I have like a few people bring their camera on? Just so I'm sure you're getting me. Cameras. Okay, I'm sure a few people are doing it already. So let's continue. I won't be the one taking you this class. So I have somebody that will be coming up to take you on this class. And so this is a quick introduction of this person. And I'm sure you're going to learn a lot. So his name is Joseph Fayoshe. He's a seasoned senior data analytics executive dedicated to providing valuable insights and boosting business growth through efficient analytical process. His expertise lies in utilization of predictive modeling and advanced analytics to inform strategic planning and improve decision-making. Joseph excels at leading cross-functional teams, implementing data-driven solutions, and optimizing operational efficiency. His primary goals is to achieve outstanding outcome and cultivate a data-driven culture within the organization. And I'm sure it will excite you to know that he has up to 10 years of experience in data. So you should by now be knowing what you're going to be getting. Just for somebody that has a lot of that much experience, you should know you're getting a lot of goodies from this class. And another thing is that he has worked with a lot of top companies in Nigeria. MTN, for example, I know a few of us, if not every one of us in Nigeria right now uses MTN. So imagine him being a lead of marketing analytics in MTN. So without no further ado, I would like you all to join me in welcoming our facilitator, Joseph Fayoshe.
All right. Good morning, everyone. Whilst looking at some names, they're sort of a bit familiar to me. Some names are sort of familiar to me in what I'm saying. I think from the record that I have, they said we have over 150 participants that registered for the session. And just about 20 is expected. People will register and they will just forget about it and they just remember and they just join. I believe strongly that by the time this class progresses, we'll have more people on board because it's not only today, we still have next week, regarding this class. Just a quick one. There will be a poll that will be pushed out in a bit. I want to just quickly answer the poll. That is why this is like a section break. Just it's a very simple poll. The poll will be launched now. We can just start answering the questions. Banjo, over to you while you push out the poll. It's a poll about okay, maybe different rules within the data space. Let's see what you're going to. So it's not like no right or wrong answers, really. It's just a career path kind of thing. It's just a career path kind of thing. Banjo, do we have the polls on?
Yeah, the polls will be coming on in a few. I'm having a bit of issues here. It's not allowing me share the polls for now. So you can just go on, just as you go on, the polls can come up. They can always insert. Thank you.
Okay. All right. So let's move on. Wow, just wait. Our agenda for today, as you can see, day one, day two. So the one is just simply introductory. And the truth of the matter is, I know some of us might be already into data, already interacting with data before now. So no hard feelings. Just it's just also to refresh your mind, refresh your memory about different concepts in the data space. While day two, which is going to be a longer duration, this one is just a very short duration. So as day two will be much longer than this because we have a couple of use cases we want to implement. So you don't want to miss day two. You really don't want to miss day two. Now, day one, it's the understanding that we're getting from day one is what we're going to sort of implement in day two. So you don't want to miss day two. As you can see that we'll be using some tools like SQL, some tools like Excel, some tools like Python to be able to implement some of the use cases that we have for day two. So I'll just zone into day one. So day one is just for us to just interact, learn a few misconstrued information, a few misconceptions, get clarity on all those misconceptions. And don't worry, the slides will be shared. You can always use the slide at any point in time that you want to use them. You see that the class rules has already been said. These are no stringent rules. We just want you all to be able to be professional because as a data people, you may not be customer facing. You may not be facing the customer. You may not be wearing tie and suit. You are the tech bro, technically. You are the guy that will probably wear shorts on the streets of Lagos or go to work in shorts. You are that tech bro. You are the ones that probably do your hair in dreads and stuff like that. However, it doesn't stop you from being professional. Being professional is not about the way you dress, about your hairstyle or stuff like that. That's what we're just trying to say for the class rules. Then we'll just explain the concept of data science. What is data science, basically? Then understanding AI, somebody will say, like the good book will say I'm of Paul, I'm of Apollos, all of those things. Somebody, we have camps. Oh, I belong to this person's camp. Oh, I am obedient, I am bad, all of those things. It's just natural that people will have camps. And I've come to understand the fact that in the world of data, people have camps. Oh, I'm an AI person. I'm an AI person. Oh, I'm a machine learning person. Oh, I'm a land. All of those things. We'll be able to understand how it sort of works. And we're also zoning into a very key fundamental part of data, which is what we call machine learning, and different types of machine learning, but we just specify the supervised machine learning. Then we'll also talk about the roadmap. For some of us that are just going to be starting, what is that roadmap? Don't worry about the whole journey. Like I said, you will see when people say, how do I start this data journey? You see, you have just started already. You see, this where you are is where you can start your data journey. You don't need anybody to probably lay hands on you for you to be able to start that journey. As you have come today, you have already begun your data journey. Then also the unseen and the seen. And you're wondering, what does it mean by the unseen and the seen? And you will get to see what it is. And the next steps are the things we're going to be talking about in day one. Just sit back and relax. You can always ask your question. Like I said, if this were a class of 3 months, for example, we'll still go through that basic fundamental. Because when you understand the basics, I tell you the truth, everything will become very simple to you. I tell you the truth. Everything becomes very simple to you. Okay, so let's move on. All right, the process of data science. I know some of us will just be funny and say that, oh, when you ask somebody, you say, I'm a data analyst. There's a way you look at the person that, this person is just a small boy, just a data analyst. He's just a data analyst, just there. And when somebody says, I'm a data scientist, there's a way you have that shoulder pad to say, I'm a data scientist. It feels like you are doing something out of this world. But the truth of the matter is, if you look at it level-wise in any company, a data analyst is not different from a data scientist. You're the same level. I won't be surprised if you are being paid the same thing, because there's a role called junior data science. There's a role called a junior data analyst. There's a role called a data analyst. There's a role called a data scientist. There's a role called senior data analyst. There's a role called senior data scientist. So you have it like that. So it's not that one is sort of bigger than the other. It's not all about that. And this is what this is trying to explain to you. You see, in the entire data science value chain, or data use case that you probably want to solve, it comes from data collection. You want to be able to collect the data. Your data sits in disparate sources. It sits in so many places here and there. Some of them will be on the web. Some of them will be ad hoc. Somebody will send you that data. Some of them will probably be on a database. Some probably be on a CRM application. It just sits in so many places. You probably want to be able to bring that data sources into one single place. The truth of the matter is, you need somebody that will talk to different sources and bring that data from disparate sources into one single source, some single place, single source. We call that source a data warehouse, for example. So you have your data sitting on the web, for example. Maybe you use intercom, people, customer interact with you. You have that sitting on that. You have a data sitting on a CRM application, you have that. You have even a data sitting in Excel, you have that. You have the data sitting in your database, you have that. You have the data sitting in the web, maybe NPS data that you would need. All of these data sets are in disparate sources, and you can't work with them except you're able to bring them into one single repository. So the guy responsible for that, to ensure that that data is cleaned, it's like you want to eat yam and somebody cuts yam for you raw like that, cuts the yam for you raw, puts it on a plate. Maybe he says, I want to eat yam and egg. And the chef cuts it raw, puts it on a plate. The egg, practically breaks the egg the way it is, with the slime, all of those things, and serves it to you and says, this is yam and egg. The guy is not wrong. It's yam and egg. It's actually yam and egg. If you look at it, it's yam and egg. But it's yam and egg in the way it can be consumed? No. It's not yam and egg in the way it can be consumed. So the yam and egg doesn't make sense to you. Even though it is yam and egg, but it is not consumable. So the same way we have data, you can't make sense of any data if someone does not serve it in the right way it should be. And the person responsible for serving that data the right way is expected to be is a data engineer. He's a data engineer. He's going to serve you the right way it's supposed to be. And he doesn't just serve you anyhow. It makes the right way means that he has to clean the data and gives you the way it's expected to be. So when you tell a chef that I want to eat yam and egg, and the chef cuts the yam into slices, very nice slices, and fries the egg, put pepper, put all of those things, and serves it with a cup of juice and a jug of water, you feel relaxed that it is time to devour this yam and egg. That is the same way data is. If the person serves you in a clean format, in something that is accessible, then you can say, I want to devour it. And who is the person that can now devour that data? That is the data analyst. That's the person that can say, this egg is so sweet. Oh, it contains the right amount of salt. It's not too peppery. The yam is also very sweet. No, it's soft. It's this, it's all of that. It can tell you how exactly the yam and egg is. The same way it can tell you what is exactly happening in your business. Something is happening. Oh, revenue is declining. Customers are leaving us. Oh, they are not subscribing. Oh, subscription has dropped. Oh, a lot of all those questions. There's somebody that will look into that data that has been prepared properly and tell you that these are the reasons for this happening. It will tell you the whys. It will tell you the whys. It will tell you the whats. It can even go further to tell you that, okay, let's ensure that this thing does not happen again. Let's be able to preempt that it doesn't happen again. So the data analyst is the one that will sort of mine the data, make sense out of that data to answer the questions of the whats, the whys, and also the preemptions, to say that this is what we need to do to ensure that this does not go out of place. Now, when he's able to know that, when you have devoured, you are able to taste, it's not that the yam is sweet, it's exciting, is bright and proper. You see, the person that actually, because they can actually serve the yam for you in paper, on a paper, on just the right way. It's not, there's a way you need to serve something that is also very exciting when you're tasting it. So for you to be effectively consumed, somebody must tell you that, okay, you need to put the egg in a small saucer, you need to put the yam in a round plate. All of those things, the actual way so that it can be consumed well. Oh, this is where you need to sit upright so that when you eat, it goes to the right place and all of those things. Let's continue that. So that's okay. So there are no labels data, no feedback is sort of given. So what unsupervised machine learning or unsupervised learning is really talking about is I don't understand what is happening within this data. But based on the fact that I don't understand, I want to be able to make sense of that data. I want to be able to make sense of it. I don't understand what data is all about, but I want to be able to make sense of that data. The supervised, meaning that, oh, I know that I made a sales of 5 million this year. How much sales will I make in the next 1 year, 2 years, and 3 years? So you made something, you know you made something. You want to use what you have made to be able to tell what you will make in future. That is why it is supervised. But for unsupervised, you don't even know how much you have made. You don't even know how those things are interacting. But there is an algorithm or there's a machine learning approach that helps you to make sense of that data that you don't have an idea of. I'm trying to explain in a very simple term, basically. I know some of you may just feel like, oh, we understand these things, but don't worry. I'm just trying to explain in a very small terms. And there's another part of learning. What it does is this. It's like, this kind of learning is like, you are telling your son that you only get candy if you do your homework and you finish your food. So your son knows that the only way to get candy is when I do my homework and when I finish my food, anytime they give me. So at the back of his mind, he knows that to get candy, I need to do my homework, I need to finish my food. To get candy, I need to do my homework, I need to finish my food. It's like a learning that uses the reward system. So he knows that, okay, when I go right, I will go left to get to the junction I'm going to. So it sort of learns by itself. So the child knows that the only time he can get candy is when he does his homework and when he finishes his food. So he knows that. So he knows that's the way candy will come. Now, that may not be the way a toy will come. So he knows that finishing food and doing homework will not necessarily give him toys, but it will definitely give him candy. That's the way reinforcement learning works. That's the way it works. So your popular ChatGPT adopts a function of reinforcement learning. So every time you type an information into ChatGPT, what it does is that it uses that information to learn. So when it gives you an answer and it says, does it fit? And you say like, no, this thing does not look like what I'm on. You modify it. As you're doing that, it's learning. So it's learning the way you ask questions. So that the next time you ask the question, you will know that, this person again, this is what he's trying to say. So that is the approach. That is what it tries to do. So it's a self-learning algorithm, like a reinforcement learning. Okay. All right. So let's zone into now. This is supervised machine learning. This is just something pictorial. I'm trying to show you pictorially so that you can make sense out of it. Now, this is your input data. And this is your input data. This is your input data. Right? Now, what a supervised machine learning will do for you is it will give you this kind of output. It will tell you this is apple, this is what's it called? Orange, this is apple, this is strawberry, and this is banana. It will predict it for you. While it will do all of these things, it will do all of these things in between what the input is and what the output is. It's able to tell you just one output at a time, 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 one output at a time. That's what it's able to do for you, one output at a time. With this customer churn, it will tell you yes or no. It's not going to tell you, yeah, yes. So, it is yes for the first 5 days. And no, it will either tell you yes or no. How much am I going to make in the next 1 year? It is either 5,000 or 7,000 or whatever. It doesn't say, you will make 5,000. At this point in the year, you will make 2,000. It doesn't do all of that. It will just tell you, oh, this is what you will make. So it doesn't tell you, apple or orange. It will tell you it is what? Apple. It tells you straight. So it doesn't give you all of these 4 options that I've written there, like 1, 2, 3, 4. It only tells you one at one point in time. That when I pick a fruit from the basket, it just tells me it is what? Apple. It doesn't negotiate. You say, it looks like strawberry. Oh, very familiar with apple. It will tell you it is what? Orange when you pick. So when I pick a fruit, it will tell you exactly what that fruit is. And it does a bit of some processes here before telling you. It will do some long process here, this process. Now, if you check very well, you will find out that there is the data collection part here. This data is collected. This data is cleaned here. This is data cleaning. Apologies for that. The data is pre-processed. Then the model is being built. Then the output is coming. So here, we have the deployment, the output that you get. This is where you have the entire step 1 to 4 that we showed earlier. And this is the output. Something that is usable, something that is at the end of the day. That is basically the way it works. That is basically the way. It can only give you one thing at a time. One thing at a time. Now, the same thing, is trying to present complex data, this complex data in a very easy to understand. So you are not interested in all of these things. It just tells you what is apple. Just pick any fruit. Close your eyes and pick it and it tells you it is apple. Close your eyes and pick and it tells you it is what? Orange. While all of this is done internally. And this is what people see. Nobody sees these parts. Nobody sees from here like this. Nobody sees all of this. And you get to see what I mean. Nobody sees it. This is the only part people see. This is the only part people see. This is the only part people see. Nobody sees all of this, but everybody sees this. And this is where the majority of the work is being done. When you do all the work here and you don't get to this point, your work done is 0. I repeat, when you do all the work here, when you do all the work here, and you don't get to this point, your work done is 0. It is completely 0. It means that whatever you have done is not usable. Because it is whatever you have here, in this region, this part, whatever you have here is what can convert to Naira and Kobo. All of these ones here does not convert to Naira and Kobo at all. It doesn't. So today, have that back of your mind. Whatever you do in the world of data and does not translate to Naira and Kobo, dollar and cents, pounds and pence, yens and yen, then it is of no value. Work done is 0. Absolutely. So at every point in time, you want to embark into a data journey, a data science journey, or a use case, have it at the back of your mind. What is the output? What is this thing going to do for us at the end of the day? So for example, if I say I want to reduce churn, I must be able to tell the business or stakeholders that before now, our churn rate is 25%. We believe strongly when we deploy this model, this churn will be reduced from 25 to 20 or 25 to 15. If you stop there, you have not finished the work. Because you need to go back to say that, okay, how much was I losing from customers churning before? That 25% that they're churning before, how much was I losing? Oh, I was losing, say, let's say 10 million. As a result of reducing from 25 to 15, let me say that, oh, instead of 10 million now, it means it's going to be maybe 7 million. Then I can say, before, my revenue is always 20 million. Now, by implementing this churn model, my revenue will grow to 23 million. So I tell a business that, okay, deploying this model will help us reduce churn from 25% to 15%, thereby giving us a revenue uplift of 20%. That is your objective. That is the objective of everything that you want to do, any data journey you want to go through. To say, okay, we've seen that customers are leaving us. Now, as a result of leaving us, we lose yearly $10 million. By implementing this model, we will reduce the rate at which customer leaves us from 25% to 15%, thereby giving us a revenue uplift of 2%. Let me go back a bit just to show you guys something. Let me go back a bit and you will see practical examples of what I'm trying to say. Let me go back to this place. Okay. Implemented a customer segmentation and profiling model, resulting in 40% increase in revenue. This is not a lie. I can give you places where you can go and ask. Automated the data engineering process by constructing a data pipeline, integrating this and this and this. This one is not a data engineering work. Created a predictive model using the integration, resulting in 140% increase in subscriber rates and improving win back. Now, the way I've written it, it doesn't mean when you say 140, that means a portion of people that were going, not the entire base, portion of people that were going before, this was a percentage increase that we had from them. This one was done. This one was done. I can show you proofs. That's what I'm trying to say. You must be able to show that proof. That proof. If it is data analysis you're just going to do, data analysis in the sense that I want to understand the what and the why. That what and why, you must be able to give recommendations to the marketing team, to the growth team, to the sales team, recommendations that they will implement, and you can track the impact of that recommendation. So the truth of the matter is, it is not about writing algorithms. I tell people, today, if you go online, you will see 1,001 algorithms on supervised machine learning. You will see it. But the question is, what is the impact of that algorithm to the business? Very important. Oh, and I know I can now deploy a machine learning model. I can do this and that. What is the impact? That impact, we call it A/B testing. You must be able to tell the impact of that model to the business. Okay, let's move on. Don't worry, if you have any question, you can ask. You can just raise up your hand. Unsupervised machine learning. Now, the same input raw data. This time I don't understand. The same thing I will do, but look at what I'm getting at the end of the day. So you can see that in here, you will notice that in here, we're able to classify some things, but there's a miss there because it's not sure. Is it the apple or this? Those are the things that happen because things are not always 100%. The same thing, you see that this is color red because this is color red. If you check very well, this guy and this guy, they almost have the same kind of shape. So he tries to see that this one is very close to this shape or all of those things like that. But to a large extent, it does the classification for you. It does this one for you too. He sees that this thing is red. Maybe based on color. So, but he's able to classify some like this, and he's able to classify all of this way for you. So the way this is arranged, the same process happens. The same process that happens with supervised learning also happens, but the output is different. It's a segmented output. So it's able to tell you that, okay, out of all this raw data, this anything that looks like this is what? Apple. It's orange. Anything that looks like this is what? Apple. And that looks like this is strawberry, and that looks like this is what? Is banana. So that's the kind of output it tells you to do. It doesn't understand what it is before, but it's able to classify them into various things. That's the difference between supervised and unsupervised machine learning algorithm. Okay, let's move on. If you have any question, you can ask. Okay, so let me ask, can I move on? Can I move on? Okay. All right. Just a section break, just for us to soak everything that we have sort of learned, we have read today. Just to give us context on what we read today. Just soak it in. And the next thing you see is a short quiz just to test whether we're following or not. Okay. All right.
All right. So there will be a poll coming up very soon. I think the first one came up and we had a bit of response. So the second one will be going live now. So Mr. Joseph, does the second poll go live now?
No. Let's make this poll. Let's do this one first.
All right.
All right. Okay, look at this, the cloud quiz. So everybody, this one, you can type your answers in the chat box. They say classify the following use cases to operate machine learning types. I've been talking about different examples that I was explaining. Just look at this use case because ability to be able to identify a particular use case and know which algorithm to use is very key and important. Okay, so let's see. I want to see answers in the chat box. I want to see answers in the chat box. So let's put numbers. This is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that you don't just type it out. Just type 1 like that. 1, 2, 3, 4, 5, 6. I'll get again 1. So let me use my mouse to be able to say something. This is where's a pen? This is 1. This is 2. This is 3. This is 4. This is 5. And this is 6. I'm waiting for answers on the chat box. I'm waiting for answers on the chat box. So if it is supervised, just write supervised. Just say 1, 2, 1, comma 2, comma 3, something like that. Unsupervised, 3, comma 4, comma 5, comma 6, something like that. Just write supervised 1, 2, 3, like that. Unsupervised 3, 4, 5, 6, like that.
Please, let's use the chatbot.
Don't worry, don't be afraid. There's no right or wrong answer. I've already said supervised learning is it tells you one single output at a very point in time. And the unsupervised, it tries to segment things for you, tries to say, it's okay, these are the people that belong to this category, these are the people that belong to this category. Based on that, I want you to look at this problem, these use cases, and tell me which one of them is supervised, which one of them is unsupervised. Are we afraid to answer? Don't be afraid. This kind of thing. So, Gabriel, you may want to write this thing again. Ephraim has given me the way I want it to be. Supervised 1, 3, 5. Okay. Ephraim, are you saying unsupervised is 2, 4, 6? So just put it there. Gabriel says 2. I don't know, Gabriel. I don't know which one I am saying is supervised and which one is unsupervised. So can you just rewrite? Okay, can they say supervised is 2, 4, 6? I like these answers. I like these answers. I like the answers I'm saying. I like that. Unsupervised 2, 4, 6. Okay. Mm. 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 Why you're trying to identify is it's important that ability to know which machine learning algorithm to be able to say this use case, this is the right machine learning algorithm is very key. Very key. Today, if you go to ChatGPT and say you want to build a supervised machine learning algorithm, it will tell you the process. It will write the code for you. It will write it for you. But if you don't understand, then there's no way you can make use of that code. You have to understand. Okay. Taylor says 1, 3, 4, 6. G says 1, 3, 5 is unsupervised. So we'll see. We'll see. Let me check the time. I will give 4 minutes more. I'll give 4 minutes more. I'll give 4 minutes more. Table says 2, 4, 6 is supervised. We'll see. Should I give a gift to anybody that gets it correctly? Maybe I should give a gift.
Yes, we appreciate that, sir.
Our anchor, anybody that gets it right, I think we'll be able to get the name. Our anchor, just watch out. And I will reach out to you. We'll give you a token of maybe 10,000 naira. Just a token of 10,000 naira.
All right, sir. Thank you, sir.
No problem. I said no wrong answer. Yes. Yeah. Yes. Yes. No wrong answer. I agree with you. No answer is wrong. I said if you get it correctly. I didn't say if you get it correctly. You see, there's no reason when you say this one. You know, when I say no wrong answer, it was the data, the career path I was referring to. The career path was the one I was referring to.
People are changing the answer already.
Don't worry, let them change the answer until anybody that the moment it is 10 minutes past 11, then we'll be able to say, okay, stop. So be looking at the thing again. I know some of us are trying to. I know you have 2 minutes more. Ephraim, I'm sorry, but I know some of us. I'm seeing the answers though. I'm looking at the answers myself and I'm laughing. Favor, yeah, you are changing mind though. Yeah, you are changing mind. Yeah, favor. You are just moving. You have been taught to and
No,
fro.
sir. I didn't change mine, sir. I
Okay,
said supervised and non-supervised, sir.
perfect, perfect.
I give for supervised and I also give for non-supervised, sir.
Okay, that's perfect. Okay, Jane says 2, 4, 5, 6. Wow. He's supervised. Wow. Okay. Okay. We have 1 minute more. 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 Okay, I think it's time up. It's 10 minutes past 11 now. Any answer that comes after now. Okay, let's see. Let's see. Let's see. Yeah, the answer we mentioned. That's the next slide. Next slide. Let's see. Okay. Now, from this thing that you have seen, this way I've put the answers like this. You will know that there are some that does not fall as supervised, and there are some that do not fall as under supervised. Can you see the way this answer is like this? Can you see? You can say that this is box 1, box 2, box 3, box 4. So there's a likelihood that box 5 and 6 will come and stay somewhere here. So if you have chosen 3 options as supervised, you are wrong. If you've chosen 3 options as unsupervised, you are also wrong. If 2 answers is supervised, you may be right. However, if 2 answers are supervised, 2 answers are unsupervised, and your remaining 2 answers are reinforcement learning, you are also wrong. Let's see. Estimating how many customers will visit your website on USD is a supervised machine learning algorithm. You are estimating. Remember when I said sales? That I want to know the sales I will get in next year. The sales I will get next 2 years. I'm estimating. Estimation means you are predicting. So you are predicting the number of customers that wants to visit your website on USD. How would you do that? It means you will go historically to your data set, maybe in the last 10 years, just to look at how customers come in on USD. What are the different nuances? What are the things that you did in those periods? And using that information to be able to tell the number of customers that will visit your website on the next USD, so that you can prepare a lot of strategies to be able to can prepare do your strategies around offerings that you want to give customer for that particular USD. Estimating how many customers will visit your website on USD. So how many of you use ChatGPT? Let me ask this question. Say the truth now. Or mute your mic and tell me I say I use ChatGPT. All right. Estimating how many customers will visit your website on USD is a supervised machine learning algorithm. Let's see the next one. Clustering customers into different groups based on their preferences is an unsupervised machine learning algorithm. When you cluster customers into different groups is an unsupervised, because you want to cluster them based on maybe their demography, their buying behavior, buying pattern, or their psychographic profile, all of those things. You want to be able to classify them into segments. You see, the purpose of this kind of algorithm or this kind of use case, what it does is this. Different segment of customers require different approaches. So if you effectively do customer segmentation properly using an unsupervised machine learning algorithm, it will be able to tell that this particular customer segment, these are the kind of products you should be able to push to them. This is the way you should communicate to them. This is what are the things that they need. Now, for example, a bank should not push credit card for maybe an individual that is probably focused on retail stores, maybe a retailer or something. You don't push credit card to another person. You push credit card to somebody that is a working class, somebody that has a salary that comes into the account at every point in time. That's the kind of person that needs a credit card. What you need to push to that guy that is a retailer is maybe SME loan, all of those things. So ability to classify customers into their psychographic behavior, their buying pattern, the way they transact with you is an unsupervised machine learning algorithm. And what it does for you is that it helps you to optimize your marketing spend. So you don't just spend anyhow. You don't just push out money like that. You are pushing out money in a targeted way. And you can be guaranteed of the kind of returns that you will get from it. So you understand the fact that there are some segments that you need to spend heavy on because they're going to give you back heavy. There are some segments that you know that you need to spend minimum on because the kind of returns you will get on them is also what minimum. It helps you be able to do, you really actualize your return on investments. I'm saying all of these things so that when you want to build a model, you need to be able to tell the business the impact of that model, how it will convert to Naira and Kobo. The next one, flagging which customers are most likely to cancel their membership. This is also a supervised machine learning. So based on the behavior of this customer or past behavior of customers, you know that when the customer is behaving like this guy will not renew. He's not going to renew his membership. So I want to be able to create an early warning sign to tell that, okay, this customer is likely going to what? Not renew. What are the mitigating actions I need to do? You see, this is just, this particular statement is actually churn prediction. You're actually predicting churn. Because if someone does not renew membership, and it stays like that for 90 days, the customer has churned. So ability to say that, okay, what can I do? So a lot of times, it really goes beyond using building a churn predictive model. You see, there's something called churn management. You see, churn predictive model is just a subset of churn management. So that early warning sign is a subset of you entirely managing that customer. Because if you can detect that this customer is going to churn or is going to not renew membership, what is that action that you want to do to ensure that that customer pays? Because it is not only that you're able to detect that the customer is going to churn or the customer is going to leave you. You need to say that, what is that action that I need to do? And sometimes your data may not effectively tell you what you need to do. So there's now a place of what we call voice of customer. So when I'm able to tell that this customer is likely to churn, what I'm going to do, one of the actions that we usually recommend to do is that get the information of those customers, push it to your customer experience team, let them begin to interact with them. When they interact with them, either via a poll, via a phone call, they can get exactly the mind of that customer. Because the truth of the matter is, data is not the end. It's actually a means to an end. Data will tell you this customer is likely going to join. It's not going to tell you what you need to do. So sometimes your call to action does not come from your data. It also comes from what? The business understanding. Can you guys see the way I'm trying to relate business understanding, domain knowledge to data? It's very key and important. I dare say that you will not find this in so many places. A lot of times, people are always running after algorithm, model. It goes beyond that. Model building, data, all of those things are just means to an end. It is not the end in itself. Are we together? Okay. Okay, this next one. Yeah, churning means to leave. No, churning churning means it has left. Sef. When you say customer has churned. So the way we usually define it is this. Is saying that when for this particular question now, let's go back one step. For this particular use case now, now it's a monthly membership. So the month of August is all going to end. Now, this guy is supposed to renew for September by the time he gets to September 1. But I find out that this guy did not renew. I can push stores that renew all of those things and does not renew. At that point in time, I would say he has an inactive membership. So before a customer churns, a customer moves from activity to inactivity. From inactivity, it moves to dormancy. From dormancy, it moves to churn. And that usually happens after 90 days. So the standard definition is when a customer is inactive for 90 days, then on the 91st day, we'll see that customer has churned. Churning could be that he has gone to a competition or he's just dormant within the system. Maybe he doesn't find value in what we are doing again. Does it make sense?
Yes, it makes sense very well. Thank you very much.
Okay, good. All right. Okay, so the next one. Visualizing cancellation rates over various customer segments. It is not a supervised, neither is it an unsupervised machine learning. Visualization, what I'm trying to do is just, you are doing exploratory data analysis. You see, this particular step can be done for a supervised, This particular step can be done for a supervised machine learning algorithm, can also be done for an unsupervised machine learning algorithm. This one too, looking at the products purchased by the highest spend of customers, is also an exploratory data analysis stage. Now, let's say, for example, I want to be able to do customer segmentation. First thing first is I want to be able to say who are sort of the top customers, top spenders. Identify those top spenders. Now, my end result of my segmentation, it could be that some top spender will fall into, let's say I'm segmenting into 4 groups. Some top spender may be under, they may not be together with maybe, let's say I have maybe 2,000 top spenders. Some 500 out of those 2,000 may not be in the same group. But it doesn't mean that they're not top spenders. So that is what all of these two things do. The first one is just visualization. They're trying to visualize just to see. And this one is also, so they are both exploratory data analysis stuffs that we do. So mainly you find here is where you find the answers to the why, the what, all of those things. This is where you find it. Are we together? So it is neither unsupervised or supervised machine learning. So nobody is winning our money. Fact. And the last one, identifying the main themes mentioned in a
sorry.
Yes.
Sorry, please. Can you go back a little bit on that last one? This visualizing
cancellation rate over. Okay, so let's say we have 3 customer segments, premium segments. You can see it says various customer segments. It means that we already have a segment already. And the segment could be premium segments. Now let's even use high value, mid value, and low value. Now, based on those 3, you want to see the cancellation rates. How does it play out? So what you're going to see is what? You're going to see a chart of cancellation rates versus what? Segments. So you're going to see something like this. This is what it's going to be. It's going to be like this. You have like a chart here. And you have another chart here. And what you will see at the end of the day will be something like this. let me use, and you probably see something like this again. I probably see something like this again. And here is just going to be maybe segment A, segment B. Where's this drawing something? So please. One second, please. So this will be, this is one segment. Sorry, please. Segment A, segment B, segment C, like that. So I'm visualizing. So here will be the cancellation rate. So this is cancellation rate. Let me call it CR, for example. This is segment B, and this is segment C. So this place will be segments in your, when you deal with Excel, for example. So this one can be maybe 20%. This one can be, let's say, 35%. And this one can be, let's say, 30%. Now, what this is going to tell you is that segments A, B are the highest segments with the cancellation rates. That's what this one will tell you, basically. So in solving for this, to solve this kind of data, what it simply means you will say is, first thing first, what is the total number of transactions that this segment did? How many of those transactions were cancelled? So you will have a table that says segment A, total transaction done, then total cancel transaction. Segment B, total transaction done, cancel transaction. Segment C, total transaction done, cancel transaction. Cancellation rate will just be the total cancel transaction divided by what? Total number of cancel transactions divided by the total transaction. That will be the cancellation rate. And you get it for each one, and you plot it. Yes, you can write the Python code looking at the data and do that. You can even do that in Excel if the data is not large. So from here, you can tell that, oh, you don't need any algorithm to do this one. You just need to just analyze the data to be able to know that this is the cancellation rate across various segments. Does it make sense?
It does.
Okay.
But I'm looking at that one now. I'm trying to see the difference between that one and clustering customers into different groups based on
these clustering customers.
Because at the end of, they're still the
these
same
clustering
segments
customers,
also.
these clustering customers, we have not put them into segments. Do you get? Yes. This one, they have been put into segment already. And this one can happen, this one can happen, this one can happen by you just defining something. It can happen at the point of a customer. Let's assume that you have high value, low value, and mid value. How do you classify high value customers? You can say that any customer that has given me maybe that has given me 20, that gives me any customer that gives me at least 5 million naira every month, for example. Any customer that gives me the 5 million naira every month, I will say is a high value customer. Any customer that gives me between 2.5 million and 5 million, I will say is mid-value customer. Any customer below that, I will say is a low-value customer. That's the segmentation. Do you know that? You have segmented that customer based on the amount of revenue they've given you, they give you every month, or the amount of transactions they do with you every month. Do you know sometimes you have segmented them like that? So you can segment customer based on that kind of information. Now, you can segment customer based on the number of times they do transaction with you. All of this kind of segmentation, we call it managerial segmentation. It means you are putting rules. You can say any customer that gives me monthly revenue, as it gives me every month, and it gives me this certain amount, I will classify them as what? Loyal customers. Any customer that has done at least in the last 6 months, that has done at least 3 transactions out of 6 transactions in the last 6 months, I will call them maybe repertoire customers. Now you are giving rules, and that there's no problem with that one. That's why I'm saying that it's not all the time you probably use a machine learning algorithm. It is not. So based on your business understanding of your space, and you are saying you are sort of familiar with that data, you can classify customers based on that. Yes, you can use SQL to write all of those things to be able to classify customers into that segment. And I tell you the truth, you can actually make something important, a very sound decision based on that kind of segmentation. Now, but there's now another kind of segmentation where you are not defining any rules. You're not defining rules at all. You don't know the rules to define. Now, you just want to put that data and put it inside the algorithm. Let the algorithm look for patterns within that data. It looks for patterns within that data, and it comes back to tell you that, oh, I've been able to segment these customers into 5 segments. Now, it doesn't give the segment a name. It just classifies them based on the patterns they are seeing. You will now look at segment 1. You are the one that will now look at segment 1 and say, what are the physical things? What are the features of segment 1? What are the features of segment 1? Okay, you note it. What are the features of segment 2? You note it. What are the features of segment 3? You note it. What are the features of segment 4? You note it. What are the features of segment 5? You note it. Now, based on that, you can now say segment 1 are customers that have this kind of attributes. Segment 2 are customers that have this kind of attributes. Segment 3 are customers that have this kind of attributes. Segment 4 are customers that have this kind of attributes. I will now go a step further to say that, can I analyze customers based on these segments that I have and do cancellation rates? Don't forget, you have already segmented them already before you are now doing their cancellation rates. Do you understand what I'm trying to say now? You have done that segmentation already. Before now, you don't know what the segment they belong to. But when you have done the segmentation, you can now say that based on this segment that this thing has done for me, can I analyze the cancellation rates of all of these segments? I can now say, segment 5, they're the ones giving me the highest revenue. Well, they're the same set of people that have the highest cancellation rates. Do you understand what I'm saying now? So now, this one that says visualizing cancellation rates over various customer segments, it's either the customer segmentation has been done already, or there is already segmented customer within the base. That is when you can do this one. It's either you are going to first of all segment the customers before you check their cancellation rate, or the segmentation has already been done, and which could be based on business rules, or it could be based on age, because you don't need any algorithm to classify customers into age. You know that, okay, anybody that is between 18 and this thing, maybe it's this, anybody between this age and this age. You don't need any algorithm to do that. You can do cancellation rate based on that. So you can say, based on this age segment, it is the middle age people that has the highest cancellation rate. You don't need any algorithm to do that. So if there is an already done segmentation, or there's already made segments within your customer base, you can do a visualization on it. But you cannot do a visualization on something that is not yet segmented. Do you understand what I'm trying to say? Hello?
Yes, I
So
totally
it has to be
understand.
segmented first before you visualize. Or the segmentation is already there and you're just trying to visualize it. So you're not doing anything. But this one, they are clustering customers into different groups based on their what? preferences. Do you know the preferences? No, you don't know the preferences. It is when the algorithm finishes that you can now tell, okay, these are the preferences. So you will group them based on similar preferences. They could fall within different age group. So it means that age may not be a major factor as a preference. Sometimes the algorithm in your data set, age could be a key factor, depending on whatever customer you are trying to serve. Age could be a key factor as a preference. Location could be a key factor as a preference. But sometimes it may not be. It depends, basically. But you don't know yet. That is why you will subject it into an unsupervised machine learning algorithm to be able to tell that, okay, this is now the preferences that I'm looking out for. It could be that your product is targeted at a particular set of customers, and your data is telling you that, hey, my guy, this is where you should be targeting. These are the set of customers you should be targeting. So you can tell that, oh, I have not made so much because I'm targeting the wrong segments. It could just be that. You could just be that, yes, you may think that your product is meant for this segment, but from data that, from your sales data that you have made, you can see that you are actually targeting the wrong segment. So what can help you to do, it can help you tweak your product and now focus on the right segment. Can we move on? Is it clear now?
Okay, thank you very much. This visualization, where does it
Which one?
fall to know?
Which one of them?
This visualizing cancellation rates.
No, that's what I'm saying. It doesn't fall any under. It can be supervised or unsupervised. It doesn't fall any under. It's just an EDA process, exploratory data analysis process within the entire value chain of your data. So this one will be something that you will show as an output in your, you have a dashboard that you're using to check the performance of your model. It can be an output. It can be an output. So it's neither supervised nor unsupervised. If I have this segment within a supervised machine learning algorithm, I can say, let me run my supervised machine learning by segments to say that, okay, sometimes you don't want to sort of mix up your data. This segmentation, this visualization can say that, let me do this prediction by segments so that it doesn't cause imbalance in the data sets, things like that. They can help you. If a cancellation rate is maybe one cancellation rate is 10%, another cancellation rate is 90%, that's an imbalanced data. Now, a way to spin this as a supervised is this. Let me spin this one. I can say, if I say the likelihood of cancellation rates, sorry, Favor, I will call you just a minute. The likelihood of cancellation rates. The moment I do that, that means this time around, I want to know the likelihood of a segment canceling. Is now a supervised machine learning algorithm. If I say the likelihood of cancellation rates, I want to predict the likelihood of a cancellation rate, then it becomes a supervised machine learning algorithm. So yes, Favor.
Okay, sir. I want to understand. Looking at the product purchased by the highest spend customer, are we classifying all that supervised machine learning? Or...
No. That's why you see that this thing I made it long. It's not under. Can you see? I made it very long. It's not under anything. It's also a data analysis step that you normally do within either a supervised or unsupervised. Don't forget that you don't just jump to the algorithm. You need to analyze the data first. You need to check things. You need to just check things out. You need to, it's like somebody that wants to toast a girl, or that wants to take a girl out on a date. You want to, before you take her out on a date, you want to know the kind of girl it is so that you know that, am I supposed to take 10,000 naira out for this date, or is it 25,000 I'm supposed to take out, or is it 50,000 naira I'm supposed to take out, or is it 100,000? You see, if you just take a girl out on a date without knowing except you're the very rich guy, that anything that comes, fine. No, you have to be able to know that, okay, this kind of girl, is she the high-end girl, or that kind of thing. That's the kind of thing you must do to your data first. So, and that is what these two things, that's what they do. These two things is what we do to our data before we say you want to do supervised or unsupervised learning algorithm. So looking at the top products purchased by the highest spend customers. So it means the first thing you will do is to find the highest spend customers. If I say favor, I want to quickly run a campaign for my top customers. Can you tell me the products that the highest paid customers usually do? If our favor, the first question I'm going to ask my line manager is, so when you say highest paid, what range of revenue are you looking at? Anybody that spends because if you don't ask that question, if you don't ask that question, favor, I know that you're not going to do the right thing. Because you need to ask me. I just said, I just want to know, don't forget my question. I want to focus on maybe give them incentive or something. I've told you what I want to do. And I say I want the products that the ISP customers are doing for me. ISP customer is open-ended. Favor needs to ask me that question to say, sorry, boss. When you say ISP customers, what range of revenue are you referring to, or transaction amount are you referring to? They say any customer that does maybe 10 million and above. Is it monthly or daily or something? You ask all of those questions. Now, Favor now goes into the database and begins to write the SQL. Say, first, I need to select customers that have given me this amount of money before. So, because the Favor will write an SQL query, select star, or whatever you're writing. He writes it and he says that, okay, I have pulled the highest paid customers based on their transaction amount or based on their revenue. I have pulled everything they've done in time memory in the last maybe 6 months or in the last 1 year. Now, people now need to take the next step to say, what are the kind of products that they purchase? You now need to write another query on top of it to say, what are the things that they are purchasing? He now goes a step further to say that these are the top products that these guys really purchase. So Favor has not done any machine learning algorithm on that. Let me go a step back. 1 second. Let me go a step back and I'll show you guys something, which is one of the things that we're going to do in the day 2. Let me go a step back. I'll show you guys something. What did I say? Okay, so you can see this thing. I said TikTok SQL interview. This thing that I've just mentioned now is actually an interview question in SQL. And it was asked by TikTok. And you will see it. It was asked by TikTok. You can see the other one I said we'll do, customer behavior analysis using SQL. I'm not writing any model here. And no model. For these 2 use cases, it's not any model. And you will see the kind of analysis that we will do based on it. So you also need to understand that it is not everything that you just say, I jump and start writing machine learning algorithm. That's one of the things I want us to demystify. That, you see, remove your mind, this entire data journey. It's not all about, algorithm. In my years of experience working in consulting, on the client side, in an agency, all of those things, I have come to realize that maybe 15-20% of the business problem is what we actually use machine learning algorithm for. I'm not kidding you. Maybe 20%. You know why? Because the proper machine learning use case usually takes between 4 to 6 months before you can implement. Iteration, it's not beans. But so every single time, every single time you are faced with a problem, you need to identify one thing. Any data problem, 2 things. what is the quick win and what is the long-term win. Because every business, no business wants to really, really stay for 6 months to be able to say that, okay, this is the value that you're bringing to the table. So whenever you see a problem, there's a use case, the very first thing within your team, your data team, you must think about the quick win first. What is that quick win? And what is that? So your data engineering, your data science approach is the long-term approach, because you'll probably take you nothing less than 3 to 4 months, maybe for a simple, not too complex use case to implement before you now start monitoring. But I mean, we can't be losing money in 3 months or 4 months. We need to have what called quick wins. So there has to be your quick win and there has to be your long-term goal. So some of these analysis, quick win analysis, will come from your very good understanding of the data itself. And the only way you can understand the data is if you wear the cap of a data analyst. When you wear the cap of a data analyst and you can mix and match that data, and a very, very fundamental tool that you will use, Python, SQL, even Excel. And thank God now, there's even Python inside Excel. You can write a Python code inside Excel now. I'm not sure if you guys are familiar with that. You know, if you have time, maybe next week I will show you guys. You can write Python code inside Excel now. So the world is changing. And with that now, with this, Excel will not have limitations of number of rows of data again. So the world is changing. So, but like what I'm trying to say is, you don't always look at it from the angle of, oh, I will always build a model. Yes, you will always build a model as the lasting solution to it, which is fantastic, which is exciting. But also the art, which is that's the ART of the data, you need to have an understanding of it. So this now, looking at products, at the product purchased by the ISP spend customers, is simply a data analyst problem. This is a data analyst. It's something you just analyze the data. Now, when you now look at this, you can now tell. So, a further use case could now be that okay, can I predict the lifetime value of every IS spend customers that I have within my system? That is now a supervised learning. I want to be able to predict the lifetime value of all my IS paid customers, meaning that when a customer has this kind of behavior, is doing well, how long do they really stay? You know, there are some high paid customers that don't last within them. They are easily moving to other products. So I want to be able to tell that if a customer comes now and gives me a revenue of 5 million or 10 million month on month, and maybe after 3 months they leave, it means that I need to find ways to ensure that I keep those kind of customers. So you can now say, based on this, you found out that your highest paid customers don't really last within your business. You can now say, I want to be able to predict the lifetime value or the survival rates of every highest paid customers. Then it becomes a supervised machine learning algorithm. Favor, did I answer the question?
Quick one. So our facilitator, we have less than 15 minutes, probably 14 minutes to go.
We'll round up. Favor, do you understand? Do you understand?
Well understood, sir. Well understood, sir.
Okay, perfect.
Thank you.
Okay, let's move on. Now that's just the classification. Now the roadmap. How do I start? Just wondering that, just so many stories. How do I start this data science? I said the journey of data science starts now. So this is me. I'm just starting my journey. Your journey starts here. This is just a standard journey. Like I said, you can learn everything in pari passu. So you learn basic math and statistics. Now, in standard data science boot camps, these are some of the first of things that they will teach you. And you see, the way this thing is supposed to be taught to you is you must know the impact. So you must have heard things like mean, median, mode, standard deviation, range, quartile, your quartile, your percentile, all of those things. You see, the business impact of those things are what makes the value to you. So what does it mean that when I calculate the mean, what does it mean? If this problem, it is the mean that I need to calculate or the average. You see, you need to know the impact of all those statistics within the framework of a business. The impact of running is 2 sample t-test what does it mean when you do an hypothesis? You see, I tell people A/B testing that people mention. I know some of us. A/B testing is just an hypothesis testing. A/B testing. That's what it is. I'm trying to make this thing simple to you. So when you hear the word A/B testing and like, don't think something esoteric. It's as if you have what? A control group and you have what? The uncontrolled group. You are trying to push out a product or a feature. And you want to see that, okay, this feature that I've pushed out, does it make sense? Which one of them is responding to it? If it is a control group, oh, it means that the feature doesn't make sense. It's the uncontrolled. All of those things you just want to test. And the same thing you apply when you build a machine learning model, you want to be able to test the impact of that model. I say these people are likely going to pick this product. Are they picking it? If I push the model to some people, based on the recommendation that I've built, are they picking it? Or even people that I not push the model to are picking it more. It means that my model does not make sense if I don't do the A/B testing. So all of those things are things that you can learn, pursue with it. So you learn basics of mass and stats. Then you also need to familiarize yourself with data science tools. You see that there are quite a lot of tools here. And my brothers and sisters, you don't need to say, I need to learn all of this. Pick one. Pick one. And you will get to see. In our use case next week, I'm going to use Excel to solve a fantastic problem. And you'll just wonder that, I didn't know Excel will do this for me. I'm not going to use Python inside Excel or anything. I'm going to use normal Excel functions. And you will see. And you will get to see. So Excel, if you're familiar with Excel, you're also familiar with Google Sheets. They're almost the same thing. Stata, Tableau for visualization, Power BI, SQL for managing large data sets, the manipulations, then your R and Python for basic programming and stuff like that. So I said, get yourself acquainted with at least 2 or 3 data science tools. So my advice would be the fact that you probably start with Excel, learn Excel very well. Yes, it says, do you have a roadmap for data analyst? Absolutely. You see this journey like this from here up to this point like this, up to this place. Getting started, learn basic math and start, data science tool. It's also the same roadmap for a data analyst. So for a data analyst, I would say you will learn SQL, Excel, Python, Tableau. I'm not even going to talk about Python or R here. If you learn Excel and SQL very well, my brothers and sisters, I will employ you as a data analyst. If you know it very well, I will employ as a data analyst and I will pay you nothing less than between 600 and 750 every month. I will employ you. If you know SQL and Excel very well, I will employ you. Because when you understand this, it's very easy for you to pick any other tool and you go on with it. I'm not kidding you. You will see next use case. You will see next week. Don't worry. Tell your friend. You will see next week. So it's the same roadmap. It's not anything. Yes, you as you may not do all these ML concepts. This ML concept like feature engineering and this feature engineering and feature selection. You will see that I will use Excel to do feature engineering. This is just language. It's just semantics. I will use Excel to do feature engineering and feature selection for you next week. I will use it. You will see. Now, and I will tell you that the only difference is just the fact that because of large amounts of data sets, I'm maybe deploying your model. And thank God now, like I said, you can now do Python inside Excel. My brother and sisters, I can deploy a machine learning model. And next week, I'm also going to give you guys something, a spreadsheet that contains different machine learning algorithms that was done with Excel. I will show you guys. I will show you. So the same process, the same roadmap. That is why you will say at the beginning, when I wrote the 5 steps, I said data analyst, I showed you where you play in. You will see that everybody needs to get started. Everybody needs to learn basic maths and start. You need to use tools. So I'm calling this ML key concept because we are dealing with machine learning. But as a data analyst, you will clean your data. You will do it here. You will analyze the data. You will clean the data. So it's the same roadmap. It's the same roadmap. Now, it's the same roadmap. You see, there are a lot of things you will see online and it can be confusing to you. Somebody will say this is the roadmap for data analyst, this is the roadmap for data engineer, this is the roadmap for, I mean, you will find out that everybody uses almost the same kind of tool. Everybody uses almost the same kind of tool. Now, you may not want to go in depth into it, but the surface level is the same. So what I'm going to do next week is, with the same thing I've shown here, I will try to give you guys, I will try to show you guys the in-depth now roadmap for data engineer, data analyst, and data scientist. I'll show that to you. But this one captures the basic of everything. I'll try and show. So I don't know the person that asked that question. Did I answer your question? Michael, did I answer your question?
Yes, you did. Thank you very much.
So I will show you the full in-depth, and you will see that it's almost the same thing. All right.
So I have another question, please,
Shoot.
if
Okay.
time will permit.
Okay, shoot.
Okay, so does it mean that you don't really require the Python, the R language, and other programming
As a data
language?
analyst, have you?
Yeah, as a data analyst, yes.
Okay, so it is not out of place if you do, it's a plus if you know all of those tools. It's a plus. And I will explain to you why it's a plus. So different companies have different tools that they use to work. And I'll give you a practical example. So there was a time so the growth team always wanted me to sort of give them a list of, what's the growth? The finance team wrote like a script for asset under management to be able to know at different times the assets that they manage across different countries in different currencies. And I asked myself that at every point in time, I've written these SQL scripts. But these guys will always, when they need this thing, and they can ask like at any time. So I'll have to go and run this query and push it to them. I told myself that you can't work like that. But because I know Python, I said, are you guys comfortable with Google Sheets? And they said yes. And what did I do? That SQL script, I embedded it inside Python. I wrote a full Python code that will go and run the SQL query by itself. It will run it by itself. It will run the query. When it activates the query, he analyzes the data, puts it in the format, and I will push it to them, to their Google Sheets. Now, SQL will not let me push it to the Google Sheets, even though I have given out the data like that. I will have to run the scripts, copy the output, and go and paste it on Google Sheet for them, or I send them an Excel file. I didn't want to do that. So I wrote a Python code that will activate the query. It will just run it at different times of the day. It runs it like 4 or 5 times in a day, just to give an updated figure. It runs it, pastes it, analyzes it, and pushes the results to them on Google Sheets. Now, what I have done like that is I have not built any model. Do you get? But I have also automated the data that they need. I've automated it to them that they don't have to come to me to be asking for it. Now, SQL will help you do that automation. Do you understand what I'm saying? It will help you do that automation. It will just help you be able to pull the data and make it in a way that you want it to be. But for them to be able to use it, it's either you give them the SQL scripts, and finance team, what's their business? It's either you give them the SQL to be running, and they'll be pulling the data themselves. We have made life easy for them. I pulled it, I pushed on Google Sheet. Another thing that I could have done was write a VBA code that will connect to it and give them that Excel sheet and say, just click this refresh button. Your data will be updated. That's another way. So now, VBA is also a kind of programming language. So the use case, what you probably just feel like, what is the output that I want to give these guys? How can I make the output more? It will relieve me of a lot of burden, and I can even serve a lot of people more. Do you understand? So in that way, I would need the knowledge of Python or a programming language. But the good thing is when you know the SQL, you know the Excel very well, you know maybe how to also visualize your data. You really, the truth of the matter is, I tell you between you and me, you are 100% data analyst, 100%. And you can get job anywhere outside even Nigeria. I work for companies not in, so I do jobs as a consultant for companies not in Nigeria. So I can tell you, you can. And I'm telling you, I say me, I will even employ you. Because I'm actually looking for people that I know that, okay, they can do this, that the work will not be too overwhelming. And I don't even need you to know how to use Python. So, but is it a plus? Yes, it's a plus. But when you know how to use Excel, SQL, and Power BI very well, when you start learning Python, you will see that the language, it's just syntax that is different. It's just syntax that is different. Or you know the Excel very well, you know the SQL very well, you know the either Power version very well. My brother, you are good to go. Quote me anywhere, you are good to go. Don't worry, I will show you some SQL simulations. You will see how long SQL can be, and you just wonder SQL that will go into about 500 lines. You're trying to solve a problem. So it's not base, because don't forget SQL is also a programming language. Have I answered your question?
Yes, this is well understood. Thank you so much.
Okay, so when you're done with all of this, it's always important that for every project that you do, you need to build a portfolio. You need to build a portfolio. You need to be able to show people that this is what you have done. You see, this thing goes beyond what you have on your resume. This data world that we're into, it goes beyond what you have in your resume. So you need to build a portfolio. I will talk more about that next class, which is one of the key things in terms of use cases that I want to do. Then, when you have built a portfolio, then you can now be getting ready to be interviewed. You can be getting ready to be interviewed. I'll clear on. This is also the roadmap in terms of programming language that you need to learn. Like I said, I will share them with you. This is things, the roadmap in terms of complexities, the programming, the maths, the data analysis, the machine learning, web scraping, the things that you would do as a data scientist, as a data analyst. These are all some of the things you would do, basically. You need to understand programming, understand data analysis, core machine learning algorithms, classification, regression, clustering, deep learning, and the likes. Then web scraping. Web scraping simply means your information can be on the web. And you can actually do web scraping with Power BI or even Excel. But there are more advanced tools that you can use, which is Beautiful Soup, Scrappy, or Selenium. Then visualization, everything culminates into what? Data science. Everything culminates into data science. And finally, there is something called the unseen versus seen. Now, this is where I said I was talking about the unseen versus seen, is the fact that every single thing that you are doing, that you're going to be doing, that looks like where you fold your arms, roll your arms, is not seen by anybody. Sorry, is not seen by anybody. What people see is the output of what they have done and the revenue impact. That's what they see. The output of what you have done and the revenue impact. I will say it again. Whether it's simple analysis you are doing, no matter how the analysis, how hard it is for you to write the SQL script or the Excel functions to get something, nothing must make sense. I'm able to present it. So when I do analysis in Excel, I was able to present it in PowerPoint to say, this is the output, and this is the money that is tied to that output. Very key and important. So don't say because I'm a data analyst, I won't be able to present, right, do a PowerPoint presentation. You must be able to present your stuff if you can do visualization, you should be able to do a PowerPoint presentation. Very important. Very important. So the output of whatever you have done and the money that they have to use, the money is important. The money is important. The CEO is not interested in your model tuning. He's not interested in your data grading, your feature engineering, your feature selection, your model building. He is not interested in it. What he's interested in is what? Naira and kobo, the money, the impact. Are we together? The impact. Very key. So a lot of things are unseen in this data world. A lot of things are very much unseen. And it will just look as if you are not working, you're not doing the work. So at every point in time, always have that mindset. It's what we call a growth mindset for a data person. that every action that I do, I must be able to attach a revenue impact to it. A revenue impact to it. Even if it's a data engineering problem you are doing, you're able to tell the business how much they're going to save by building this pipeline and how well it will make data available at the speed of light. That way, you can tell them this is the impact that I'm putting to the business. Are we together? Very important. So a lot of your work is unseen. You are the guy at the back end, nobody is seeing your work, but the only way they can see the impact of your work in any organization is if you can tie it to what? Naira and Kobo. And that brings us to the end of this. Data is a small part of the growing number of suppliers in the business. Yeah, that's small, but growing number that supply value to every business.
All right, so thank you very much for that impactful class. It was very, 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 very impactful. I think somebody just raised his hand now. So somebody just, is that Favor? Person that raised his hand. Do you have...
I didn't raise my hand. I gave a reaction like I clapped.
Oh, okay, cool. So I want to use this opportunity to thank our facilitator. He has done a very good job. Like you all have seen and heard, learned a lot. I can say that. So just for a reminder, this class will continue by next week, and that one is like very, very, very important because it's like a major part of learning what you came here for. So I'll be dropping the links to our social media and those on the chats. I don't know if the link will be clickable. So just you can copy it and put it on your WhatsApp or anything. So you can follow us on Instagram or Twitter or LinkedIn. Just so when there's any information that needs to be passed before next week Saturday, you can get it. Be passing a lot of information, probably things that you need to come prepared for what you'll be needing for the class and stuff. So you need to follow us to be able to get those information. So with that being said, I think that will be all for today. So don't forget to, yeah, Jane, you're welcome. Don't forget to follow us. You need to do that. If you can do that now that we're still on the call.
I think Favor has a question. Favor, are you raising your hand?
Favor, are you?
Yes, sir. I'm trying to hear you, but I find it very difficult. You're not really audible enough. So I want you because
is it me or the?
No. I'm talking to the host, sir.
Okay.
Yeah, so I don't know. It's not still clear, but I can hear Mr. Joseph well. I can hear Mr. Joseph well. But I'm finding it very difficult to hear you, sir.
Yeah.
Can any other person, is any other person having the same issue? Mr. Joseph, can you hear me from your own side?
Yes, I can hear you, absolutely.
Okay, I don't know
I can hear you from my end too.
It's better now, sir. It's better now, sir.
Okay. So like I said before, just try to follow us on our social media so that you can get any information that we need to pass. And I wanted to ask, did you guys get any reminder this morning, an email to join this class? Did anyone get any reminder?
Yes, I did.
Okay. I just needed to be sure that.
Yes, I did. I got a reminder.
All right. So the same reminder will be going out by Saturday morning next week, so that you guys can be reminded of the next class. So I'm sure you guys have followed our social media handles now, just so you can get all the information that you need to get. So I think someone is raising. Michael, are you raising your hand?
Yes, please. Thank you very much. How do we get the slides that was used during the presentation?
Okay. For the slides, I think it should be able to. I think it will come in during the week. But Mr. Joseph.
Yes, I think you will get it from social media guys. They will send it to you via an email. I think we all have your email, so they will send it to you. Also, tell your friends next week is the proper use case implementation. Come one, come all, and you will see how we do all of these things and so on.
All right. So
communications will come before then via email. So watch out for your email and stuff like that.
All right, just so everybody knows, this class is being recorded, so most of the information you've gotten here, you can still go back to it. So when it's available, you get all this information from our social media. So it's to be better for you to follow us on our social media. And if you have people that will be willing to join us next week, you can tell them to also follow us so that they can get when this recording is coming out, just so they can prepare themselves for the next class. So with that being said, I think that is all for now. Thank you once again for joining us today. And we hope you've gotten a whole lot of value for your time today. And I'll see you guys next week. Thank you for joining. Have a wonderful weekend.
Thank you so much, sir. We're very grateful. Thank you so much.
Take care.
Thank you. Thank you, everyone. Thank you.